got one. So the theory behind what we're going to do today is complicated, but when we get to the end, it's really not that hard. I'm going to say it's like, the notes cover like how the car works, but at the end of the day, you just need to know how to drive the car. And so, you guys are smart people. You could explain some of how your car works, but you probably can't explain all of how your car works. But you know how to work your car. So I'm trying to explain a little bit of how the car works today, but at the end, it really won't be that bad. And the car today is inverse trig functions. So it looks complicated, it sounds complicated, and the inner workings are complicated. But we get to the end of today, and it's like, well, do you know how to drive the car? Yeah, you can drive this car without understanding all of the background. So, having said all that, we'll even skip some of the notes. Like, we'll do the sine function kind of all the way through, and then we'll just be like, hey, cosine and tangent are kind of the same. Here's the answer. So, let's jump in and learn how the car works, and then we'll talk about how to just drive the car when we get to the end. All right, inverse trig functions. So, a lot of words going on here. First, a reminder about notation. The notation for an inverse is -1. And this gets confusing because -1 is also sometimes 1 over, right? 2 to the -1 is 1/2. X to the -1 is 1 over x. But f -1 is not 1 over f because this represents the inverse function. So be careful with your vocabulary and your notations when we start doing inverse functions. Do you recall how to find the inverse of a function?
Switch y and x.
Good. So let's switch x and y, or I'll phrase it like you did. I don't know why it matters. Switch y and x. So this one would be x equals natural log 3y minus 7 over 5 minus 2. And then we need to do a little algebra to get y by itself. So I'm going to add 2 and multiply by 5. So 5 times x plus 2 equals natural log of 3y minus 7. Did a couple steps at once there. How do I undo the next step, or what do I do next? Okay, both of those answers are right. So you can raise both sides to the e, because e to the natural log would cancel each other out. The same thing is the fishhook thing, because that would be e to the other side equals 3y minus 7. So e to the 5 times x plus 2 equals 3y minus 7. So you can e to both sides, or you can fishhook. It's the same thing. So let's add 7, and then divide by 3, and there's our inverse function. Switch x and y, solve for the new y.
Do you have to put y -1?
The best answer would be g with a -1, because you're telling me that that's the inverse of g. All right, do you remember how to determine if the inverse of a function is a function?
The vertical line.
No.
So the vertical line test tells you, maybe we need to back up. Vertical line test, that's a good word. Horizontal line, yes, they're all right. Vertical line test answers the question, is f a function? So that's the one you learn in 8th grade, 7th grade maybe, I don't know, somewhere in there. Vertical line test. Is it a function? Got it. But if the inverse of f is a function, then there's 2 ways to say it, and I wasn't sure which way, but I heard both of them. So if f passes the horizontal line test, and that sort of goes with the next blank, which is the phrase Dia used. The inverse of f is a function if f is 1 to 1. That's the fancy word for, if we're thinking about the pictures of functions like this, 1 to 1 means they're a 1 to 1 tie. They're tied up 1 to 1. So that's a little background reminder of functions and inverses, and is the inverse a function. So there's the graph of sine of x. Let's ask a first question before we get to this question. Is f a function? Definitely, right? Passes the vertical line test. If you plug in any value, you get one value out. We're good. Is the inverse a function? No, because if we draw a horizontal line, it intersects a whole bunch of times. No, it's not 1 to 1. It fails the horizontal line test. Like that's the same thing, phrased a little differently. But we need the inverse to be a function, right? Your calculator has an inverse sign button on it. We want there to be an inverse, so we have to sort of force it into 1-to-1-ness. We force it to pass the horizontal line test. And so to force that to happen, we're going to restrict the domain. Meaning, if I look at all of this graph, it definitely fails the horizontal line test. But if I say, well, what if I narrow down the window I'm looking at? I could make it past the horizontal line test if there's a whole bunch of windows you could pick.
Just from take half a period.
Be careful with saying half a period, because 0 to pi is half a period, but that would fail the horizontal line test.
A quarter of a period.
Well, a quarter of a period wouldn't get all of the values. So you're right, you want half a period, but which half do you want? You want to catch all of it, so let's do, well, but not peak to peak, because then you'd fail the horizontal line test. So half of peak to peak, or from a minimum to a maximum. That's maybe the best way to say it. Now there is something kind of weird going on here, and that is the pre-cal committee that decided that, they didn't have to decide negative pi over 2 to pi over 2. I mean, I'm glad they did. But if they had chosen 9 pi over 2 to 11 pi over 2, that would still be 1 to 1.
Yeah.
That would be a weird choice, but it would still be 1 to 1. Fortunately, they picked negative pi over 2 to pi over 2. So if we throw out the rest of this, then we're able to go backwards. Remember the classic example is, if it's 1 to 1, that means, if we think of the vending machine, a vending machine that functions correctly means you push the Dr. Pepper button, you get a Dr. Pepper, not a Dr. Pepper and a Sprite.
The school ones are so bad.
The school ones are not 1 to 1, because if you push any of the buttons, you get a water, right? That's one of the vending machines is like that, like all water. And so if you're standing there, or like that whole row is Coke Zero.
One of them works.
So it's not 1 to 1, because if you see a friend standing there with a bottle of water, you can't go backwards. You don't know which button they pushed, because they could have pushed any of them. Now you're thinking about the school vending machines. So we're going to restrict it so that we can go backwards. So that if the answer is 1, we know the angle is pi over 2. Okay, so we're going to restrict the domain. We're going to say the same thing 3 times here. And we're going to restrict them so that it's close to 0, right? It wouldn't make sense to restrict it 9 pi over 2 to 11 pi over 2. I mean, that would be dumb. So arbitrarily means they could have picked a different domain, but any other choice would have been kind of weird. By the way, the parallel here is one you're more familiar with. What's the square root of 9? 3. Why is it not negative 3? It's like, well, if I square negative 3, I get 9. But someone long ago decided, you know what, if we take square roots, we're going to get positive numbers. They just said that's going to be our answer. Because we want there to be one answer. Same thing here. If we're going to do inverse sine, I want there to be one answer. And it needs to be between negative pi over 2 and pi over 2. There are other possibilities out there, but we're not allowed to use them. Just like the square root of 9 is not negative 3 and 3. We've decided we're only going to use the positive. So inverse sine, every value has to be between negative pi over 2 and pi over 2. Oops. Brackets on both sides. Now, when we use this, your brain is still thinking unit circle, as it should. And negative pi over 2 to pi over 2 on the unit circle is quadrant 1 and quadrant 4. Just be careful. Quadrant 1 if it's positive, quadrant 4 if it's negative. If you use quadrant 4, make sure you use the negative angle to get there. Don't go all the way around. Right? Because we have to be between negative pi over 2 and pi over 2. Okay, let me back up and briefly do the graph of sine of x, but only from negative pi over 2 to pi over 2. We saw it, but it's on the previous page now. So there's the graph of sine of x. Do you remember what reflection is made in order to get the graph of the inverse? You might be able to tell by looking at those pictures. It's none of those. If you reflect it across y equals x, because that's what you did to get the inverse, you switched x and y. So you let x equals y and y equals x. I think you can maybe see that there's our inverse of sine. That's why it looks like that other, it's curved the other way. And by the way, if we hadn't restricted the domain, then we'd have, right, if we graphed all of it, but then it would fail the vertical line test. But that's why we threw out the rest of that, so that when we did the little flip, we still have a function. Okay, all of that is sort of under the hood of the car. To drive the car, all you need to think about is, if you're dealing with inverse sine, your answer needs to come from the first or fourth quadrant. And again, if it comes from the fourth, use the quickest way to get there. So even if you forget one-to-one and horizontal and vending machines and graphs, just inverse sine of 1/2 means find me an angle whose sine is 1/2. So go ahead, tell me an angle whose sine is 1/2. Let's see, even if you need to draw a picture. So that would look like that or that. But I have to pick from quadrant 1 or 4, so it's pi over 6. What we're doing today is the unit circle in reverse. I'm giving you the answer, you're giving me the angle. But you're only giving me one angle, right? 5 pi over 6 has a sine of 1/2, but it's not between negative pi over 2 and pi over 2. That's it. So yeah, so I tried to say, like, all the under the hood stuff seems confusing, and then you get to the problems and you're like, wait a minute, you're telling me all this means is find an angle whose sine is √3 over 2. So, what'd you say? Find an angle whose sine is √3 over 2. Pi over 3.
Does it say arc sine?
Arc sine is the same thing as the inverse. And it helps alleviate the confusion with the -1, right? So it's not 1 over, it just means go backwards. It's also easier when you're typing a worksheet to type in arc sine than to put an exponent there. But you should see both, so we do both. Okay, the -1s are what mess people up sometimes. Find me an angle whose sine is -√2 over 2. Okay, so yes, 7 pi over 4 has a sign of negative root 2 over 2, but it has to be between negative pi over 2 and pi over 2, meaning you can go to that spot, but rather than go the long way around to get there, why don't you go the short way around to get there? Negative pi over 4. And that is by far the most frequently missed type of question in this on this section, because they know it's over 4, they know it's in the fourth quadrant because that's negative, but someone's going to say 7 pi over 4 instead of going the short and easy way. So how about inverse sine of negative 1/2? Negative pi over 6. And again, sometimes you draw pictures to help you. Sometimes you know them so well that you kind of visualize it and you just give the answer. That's fine too. Why don't you try the next 5? Whoa, all 5 of them.
That's not as
Yeah, so it's like you just go back.
You just go backwards, but you're restricted on where you can look.
Oh, and now we're in the
Okay. Okay. Cosine. Let's don't talk about all the stuff under the hood of the car. Let's jump to how to drive. Cosine.
It's just like, this is gas.
Right. I mean, you know a little bit of what's under the car, but you don't need to know how everything works. That's a lot. So with cosine, you can't use 1 and 4 because cosine's positive in 1 and 4, so you wouldn't have all your options there. So for cosine, you use 1 and 2. For cosine, you use 1 and 2. So the inverse cosine of 1/2, let's see, that means I need an angle whose cosine is 1/2. So, yep, pi over 3. Also negative pi over 3 or 5 pi over 3, but those aren't in my restricted domain. I'm only allowed to look from 0 to pi. You know what? Maybe we should have peeked under the hood a little bit. There's the 0 to pi to make it 1 to 1. So it's a different range for cosine. All right, how about an angle whose cosine is root 3 over 2? Yeah, pi over 6. Pi over 6. Ooh, a negative one. Inverse cosine of negative root 2 over 2. Wait, what did you say the answer was?
Nothing.
I mean, it's right there. What's that angle? 3 pi over 4.
Oh, I said that. Wait, did we write down
So we didn't. Maybe we should have. I jumped to driving a little too quickly on this one, I guess. 0 to pi. 0 to pi. Because I don't really think 0 to pi and negative pi over 2. I think more in terms of quadrants. Because this is unit circle stuff. So your brain ought to be thinking in terms of quadrants. So maybe we should put it here. Quadrant 1 and quadrant 2 is where we're looking. And if we look at the picture, quadrant 1 and quadrant 2. So cosine, you're in quadrant 1 and 2. Sine, you're in 1 and 4. Even that, there's still an easier way to talk about that. Why don't you try the next 6 this time? I get to call lots of volunteers. Whoop. Ohm is in a different class now. I think he's in 4th. I think. Mariana. So briefly show the answers to those last 6 that we did. And then to restrict the domain for tangent, you probably just want that middle one. Negative pi over 2 to pi over 2. Brackets because of asymptotes. Parentheses, thank you. gave the wrong answer with the right reason. So if you're thinking unit circle, and this is how I remember them, and we'll put them together in a minute. Again, I'm thinking quadrant 1, quadrant 4, and if I'm in quadrant 4, you have to get there the quick way, not the long way. You don't go all the way around. You go the quick way. So how about the inverse tangent of square root of 3? This is where knowing the tangent 3 trick is helpful rather than trying to figure out going backwards. How about the arctan of negative root 3 over 3? Well, there's 2 3s, so it's definitely a 6. And it's negative in the second and fourth quadrant, but I'm not allowed to go to the second quadrant for tangent, so negative pi over 6. Not 11 pi over 6. You have to get there the quick way. Why don't you try the next 6? The limits are a little bit tricky, maybe. Tell you what, try 6. I'll pull popsicle sticks for the first 4. We'll do it that way. So there's the 4 easy ones. Here's the graph of the arctan. So limit as x goes to infinity. You know what? You can kind of, yeah. You sort of plug it in. You're not really allowed to plug in infinity, but that's kind of what you do. The question is, where is tangent equal infinity? Well, it never gets there, but it's close to that at pi over 2.
So it's asking the asymptotes, basically.
Kinda, yeah. It's an asymptote question.
So then, yeah, because the next one is negative.
And the next one is negative pi over 2. Okay, the next set is not bad because...
Wait, can you explain the limits again?
Yeah, one more shot on the limits. So, 2 ways to do it. One is, and this is the first way we do it in calculus, is plug in the value and see if you can figure it out. So, this is not mathematically accurate because I can't take the inverse tangent of infinity, but I can think about it, and I think about the graph. You know, where is tangent going to infinity? Well, it's going to infinity at pi over 2. And where is it going to negative infinity? At negative pi over 2. The other way to do it would be if you have a graph of the inverse tangent, which we do right here, then as x gets really, really big, your graph is approaching pi over 2. And as x gets really, really small, your graph is approaching negative pi over 2. But you would need the graph to do it that way. So the first go is usually plug it in, and you can't really technically plug it in, but you can think about where does the tangent get close to infinity. All right, the domain restriction for cosecant is the same as sine. Right, they're reciprocal partners, so they go together. Secant goes with cosine, so they have the same restrictions as well. But we have to be careful with tangent and cotangent because it's flipped, but it's also shifted. It seems like restricting our domain to this piece would be best. That's 0 to pi. So if they had kept it negative pi over 2 to pi over 2, it would still be 1 to 1, but there would be an asymptote in the middle of it, and it would be really weird. Yeah. So if you had gone negative 1 to 1, or negative pi over 2 to pi over 2, like tangent, that is a 1 to 1 function, but that's weird because there's a asymptote in the middle of it. So it's like, let's not deal with the asymptote. Let's go 0 to pi. Okay, here's the best part of this lesson is it's summed up in a picture.
Oh, black hole. None shall pass.
None shall pass. If you're, I don't don't know, this was a little different than how I draw the picture. So I'm going to draw it over here, even though it's the same. So quadrant 1 and 4 is sine, tangent, and cosecant. Those come from 1 and 4. From 1 and 2 come the other ones. Inverse cosine, inverse cotangent, and inverse secant. So everything's positive in the first quadrant. If it's negative is where we have to be careful. Although you really don't have to be careful. As long as you stay out of the third quadrant, you're going to be fine. Because if you're doing inverse cosine of a negative, that's in the second or third. But if you have to stay out of the third, then you'll land in the second. If you're doing inverse sine of a negative, well, that's third and fourth, but you can't be in the third, so it's got to be in the fourth. So there's a lot of theoretical one-to-one horizontal line test, inverse function talk going on. But really, you just need to remember sine and his friends come from quadrant 1 and 4. Cosine and his friends come from 1 and 2. And if you want to get even simpler than that, stay out of the third quadrant and you'll be okay. And not just stay out of it, like don't even go through it. Meaning if you're in the fourth quadrant, get there the quick way, not the long way. You shall not pass through the third quadrant. So we got a mixed set here. Let's try those first 6. Oh, and that's everybody. So everyone's back in the draw pile here. So you're now eligible. Oh, 4 looks tricky because it's like this nested thing, but that's fine. These people are more than capable of handling those. For those at home. So your assignment today is worksheet whatever next is 6. Nope, worksheet 5. And yeah, it's a lot of questions, but if you know your unit circle, they go quick.